Hello everybody, macroeconomics, and we are now within our theoretical part. So we will start from a rudimentary basis to build up a model for describing the whole economy. And well, maybe you know my CV that at some time I converted from a physicist to an economist. And well, when I did this, I was very practiced in doing mathematics, so I just looked starting to study economics just at the theoretical part, doing all the theory, and was quite happy. So I didn't very much care about this first slide. And then during my years, especially when I did my PhD, I found out that this is the important thing of economics, because what we want to do is we want to describe our own behavior. And unfortunately, or not unfortunately, social science is not natural science. In natural science, we can always, within a specific framework, redo and redo the experiment in order to see, does our model fit or does it not fit? And in social science, we want to describe our own behavior. And yeah, anyway, if we are living in a democracy, in a dictatorship or whatever, we are always can do what we want. Well, it always has other impacts doing what you want. Uh, but anyway, of course, also we do not have to behave what we call in economics rational. We can start to buy more when prices are increasing. This is not forbidden, but especially in macroeconomics, we want to describe the economy, the society on average. So what will happen, or how can I in general explain where the economy is going? And for this, we have to make reasonable assumptions. And of course, then we have to test our assumptions and our model. What happens within the model? Is it possible to describe with this model then reality? And yeah, for this, if we again go through these assumptions in the so-called Keynesian economics, or what we are starting here is the Keynesian commodity market, that these are all very strong assumptions. And what you should really care about is not, do I really fully find these assumptions in reality, especially, well, of course, in reality, we know that prices are adjusting. But in order to, yeah, to find really the core of the argument in the end, for this reason, in theory, we make these strong assumptions. And in the next lectures, in the next weeks until December, you will also see that we are starting to relax these strong assumptions in order to come to a general model where we can say, well, okay, this we find then also in reality. But of course, in opposite to natural science, we will not find the right description of the economy, because it's a description of our own behavior. And we always can do it in an opposite way than the assumptions within the model. And therefore, yeah, not the mathematics, which is also coming, which hopefully you also will manage. It is not very hard mathematics what we are doing, but the maybe more important part is that you understand the general assumptions. And then, yeah, mainly we are using in this introductory lecture then, yeah, just linear functions. When we come then to, in the end, to the neoclassical view, then you will find also a square root, 1 over x, and something like this. Of course, in growth processes, we have the exponential function. In quantity theory of money, there we use the log. But in the end, it's these 5 or 6 functions which you should be able to use them. Yeah, so we are in this starting part in a demand side view, and we are not at the peak of the economic cycle, so we still can adjust quantity, and this is absolutely needed, because if you think in the end GDP is price times quantity, if we are 10% above potential output, so overtime working, every machine is 24 hours running, and so on. Well, of course, then prices will change. So these two assumptions, they match, so to speak, together. An assumption that prices cannot adjust needs that the capacities are not fully utilized. And yeah, then demand side means Herrn Eck. The first one is demand, and we have a process that in the end we have an equilibrium that supply and demand matches, but yeah, we say that the first one is demand and then the supply side adjusts. So we have some investment and consumption plans, and then the supply side is following, but it is not following via price adjustments. Okay, and then we came to the abstraction that we then said, well, we already have seen this demand side view for GDP, and there we said, well, it is consumption plus investment plus government expenditure, and for simplicity, we skip the trade balance at this point. And well, and when I switched to economics, then I said, well, this I know, some letters, putting them together, these are functions, great. I have done this for the last 6 years when I've studied physics. But then hopefully you already see, if you see just these letters and you know what they are meaning, that you then also have an idea of the quantities behind it. And here we said for Germany explicitly and in general for developed economies, then we know, okay, consumption is something around 50-55%, maybe 60 of the overall production, of the overall income. And investment and government expenditure, both roughly 20%. And then the last missing 5% would come for Germany from the trade balance. If we go to the United States, remember it's the other way around. They have a deficit. So there, these three numbers would add up to more than 100% because this in the United States is a negative number. This is what is about with this crazy guy introducing all his tariffs, or not, because he is switching his opinion during a day 3 times. Yeah, and then we said in order to obtain a model, we need some functional dependence, and then we said explicitly that consumption itself is depending on the overall income in our economy. And this you know from what you have defined as normal goods, that in general we see, and this is now a behavioral assumption, the richer we are, the more we consume. This has not to be the case for every individual, but on average, we see this also in the data. And then we start to model this with this very simple function that we say, well, it should be just a linear dependence. But with a marginal consumption rate, which is not 100%, well, in general, you could even think of in a realistic way that this number could be larger than 1. Because you could say, if I get additional 100 euros, then I take a credit of 20 euros, and so I will spend 120. But in general, we don't see this. We see in general that this number is less than 100%. But this is, of course, also an assumption, and we find here again this autonomous consumption, but this is not something like the existence minimum. So the argumentation behind this is not, well, I still have to consume when I have nothing because I have to something to eat. This you find in these funny videos in the internet, but this is totally wrong. Because that we have this part here is again due to the fact it comes from the data. And the data says us that the average consumption in a society, in an economy, is falling with increasing income. So we said C over Y, total consumption, 55% in our society over income, that if we become richer, we should not be surprised that this number is falling. That we then consume relatively to income only 50% or 45%. And if you look in general at the countries in the world, you look at developing countries, emerging markets, and developed countries, to use these three general categories, then we see that in developing countries, Africa, Southeast Asia, or some parts of Southeast Asia, Bangladesh, or Pakistan, some countries like this, that there the relative consumption number is not 50 or 55%, that it is in general higher, 60, 70% of overall GDP. And in the developed countries, Europe, United States, Japan, and so on, there you see, well, they are relatively richer than these countries, that they do not consume that large proportion. And a possibility to model this finding in the data is just to introduce here a fixed number. And this I have showed you yesterday, because if I then just write down in the functional form what is C over Y, this is C0 over Y times the marginal rate of consumption. Remember again a fixed number. This is somehow a function 1 over x. Of course, 1 over x is falling if x is increasing. So this is the technical part of this. But then we see this technical property of the function matches with reality. Okay, and or in general, I also said, well, I want only the property of monotonicity, and for this I take the first derivative of this function, and this is minus c0 over y squared. Y squared is a positive number. C0 is a positive number. Positive divided by positive is still positive. If I have a minus sign in front, I know this is a negative number. First derivative negative means decreasing function with respect to this variable. Or what we also can do is, let's take this derivative in a very general form. Let's say this is average consumption, AC over Y, average consumption. And then the first derivative of ACY with respect to Y, so AC prime. And remember, AC is C of Y. Oops. No, no. Why is it not working? My pen? Uh, the mouse working? This is working? But this is not working. Anyway, so I have to use both hardware. Up. C of Y of Y. So this is a function of Y, this is a function of Y. In order to get the derivative of a proportion, what do I have to do? So now I forget about this functional form. I just say I have in the numerator and the denominator just a function of x. What do I have to do? Hopefully you remember, if you have a function u of x over v of x, what is f prime? So this is u prime v minus u v prime over v squared. There, hopefully in school you have learned, I think it's about 6 general rules for taking the derivative of functions. So if we apply this here, then of course we obtain c prime of v times y. We are just dividing by y, so v is equal to y minus function itself, c of y. And what is f of x equals x? What is the derivative? Pardon? No? 1, of course. This is just 1, and multiplying a function with 1 is the function itself. So I skip it, just divided by y squared. And if I now use this specific functional form, then of course I know that c prime is just the marginal rate of consumption. Well, we have just defined it in this way. So I obtain cy times y minus, and this is a minus bracket, c0 plus cy times y over y. This and this just cancels. So I'm happy because I have, oops, the same result as I had it here. and still this was a negative number. Well, this calculation, hopefully you have already seen. So not with this is consumption and so on, and income, but just this technical calculation you should have already seen, hopefully in your introductory course, business administration, investment and financing, or of course, again in microeconomics. Such a function here, c of x is c0 plus cx times x. And I think also with the letter C in business administration, what kind of aggregate are you calling just a function of C? Cost. And I think such a function you have already seen. And how do you then interpret this first part in cost theory? Fixed cost, of course, this is not depending. There, X is your output, so this would be fixed cost. And this part, variable costs. And what you then hopefully have done is that you had a diagram like this. That this would be AC, average cost. This was C of X over X. And this was MC, marginal costs. And what this point here, this should be the minimum of the average costs. How did you call this? No, not the market agree. Pardon? No, I mean now just the point here. What? The minimum of the average costs. Oh, yeah, maybe break-even point. But I don't think so. But I don't know what my colleagues have said. So break-even is possible, but it is not the general. Yeah, the minimum of the average cost. Maybe production optimum or something else of your. I don't know what my colleagues have said, but it is, of course, a specific point because then you said, well, this would be the starting point and the rest of the marginal cost function would be what? Just your supply curve. So, and in order to show that in this point the marginal costs just matches the average costs, what are you doing for this? Of course, you are calculating the derivative of the average cost because you want to calculate the minimum, and then you know when the first derivative of this function is 0. So if this would be 0, then since I know it is convex, I know that I'm in a minimum. So if this is this should be 0, then of course I do not have to care about the squared number here. I just multiply with this and then it vanishes. So this part has to be equal to 0. Now let's take it with x, then c prime of x times x minus c of x equals 0. So I obtain C of x is C of x over x. This is average cost, this is marginal cost, and I have technically calculated that within the minimum of average cost, both curves have to cut itself. Well, and then hopefully, because this is only, so to speak, my mathematic explanation, then I was fine. I said, well, I've showed it. But maybe the more important thing is, well, is it reasonable? If I go into the production process of some enterprise, well, and then you say, well, I see that I have these two parts, a fixed cost component and a variable cost component. The fixed costs are always there. When I start production, let's say you have a large production center, which is your fixed cost of €500,000 or something like this. Then, of course, these costs are there when you are starting the first unit. And then means the first unit has to carry the whole fixed cost. If you are producing the second unit, then the two units are still carrying the whole fixed cost. But if it's 500,000, every unit has only to carry 250,000. And then you go on over 3, over 4, and so on. And then you say, well, on average, this is the fixed cost regression. It is going down. Per unit, the fixed costs are decreasing. But then you say, well, if I'm producing 1,000 units, calculating fixed cost over 1,000 or fixed cost over 1,001, the number is more or less the same. And this means you should know how 1 over x looks like. If I'm in the area here, the number is not changing anymore in a large amount. But on the other hand, I know when I'm start to produce, and this is a definition of variable costs, the variable costs are increasing. And as I said, in the beginning, 500, 250,000, this is very steep. It goes down very fast. So although I assume that the variable costs in the beginning also are increasing, the decrease is much larger of the fixed cost per unit than the increase of the variable cost per unit. So I'm overall still falling, so I'm in this part of the average cost. But then in the end, when I'm reaching for the fixed cost, this area here, the decrease becomes smaller and smaller and smaller. The increase of the variable cost per unit becomes larger and larger and larger. And there has to be some point where the decrease just matches the increase. And what is it? This is just the minimum. Because afterwards, average costs, because of the overproportional increase of the cost side, increases more than the decrease of the fixed cost. Okay, so when I started to lecture, this I hadn't seen, but then over the years, then I saw, well, this is the same calculation in micro and macro from totally different aspects. Here we are talking about consumption, and there we are talking about costs of an enterprise. But what we have to do analytically is totally the same. And therefore, these general skills, how does a function look like, and so on, this is very, very helpful. Okay, so, but then we put everything together. Demand side view, we said overall demand is consumption plus investment plus government expenditure, and demand side view means supply is following. So we just now match demand and supply via this equality. This is our equilibrium condition. This condition means demand equals supply. Well, and actually now we are done. This is then our overall model, just this equation. And now we want to go a little bit in more detail, and of course diagrams are helpful. We now want to interpret how does it look like, and yeah, what are the properties of this equilibrium. So at first, about this I have already talked. We have to have also an idea what are the quantities of the numbers, and there then we find, remember the circular flow. For Germany, roughly we have a savings rate of 10, a little bit more. Right now it's about 11%. What does it mean together with our assumption, these Keynesian consumption hypothesis? Positive dependence, but lower than 1. Here explicitly 0.89, because then we can calculate the marginal rate of consumption, because savings plus consumption is 100%. So just 1 minus the savings rate is our marginal consumption rate of 0.89. And this means if we have an additional 1,000 euros, this means that I directly spend, I increase my consumption by 890 euros. Okay, how does our consumption function looks like? Well, let's assume our C0 should be 100 in order that you see here these numbers. Then this is, as I already mentioned, just a linear line. The 100 is the vertical cut, and the 0.89 is the slope. And the slope is also that the change of consumption divided by the change of income. So also delta C over delta Y is Cy slope of the consumption function. And well, when I now start to explain to you this model, I will quite often use explicit numbers. But in order to understand a model, you have to try to think just in variables, in these letters. Because what we then in general will ask, not autonomous consumption is increasing from 100 to 150, but we want in general answer the question, what happens if the autonomous consumption is increasing? Or later on, what happens within our economy if we are increasing government expenditure, so an increase of our variable G. Okay, here, this is just our part of the model where we have a functional dependence, and this now we want to put together in our overall equilibrium condition. And there we had y equals yd equals c0 plus cy times y plus I plus g. Let's assume, now a little bit easier, c0 is our 100, cy I will take 0.9, I let's say is 50, and g let's say is 20. If I insert this, I obtain 100 plus 0.9y plus 50 plus 20. If I want to draw this function in my diagram, and here you see on the vertical axis, we write down our demand function c plus I plus y, g, and on the horizontal axis, I have my income. So hopefully you can explain me how should I now draw this function in my diagram. What should I do? Hmm? Yeah, and what number is it? 150 and 20? No, 50 is not income. I is investment. 170, okay, plus 0.9 times y. And how shall I draw this linear line? And you should see that this function is a linear line. Yeah, this what you are doing with your hand seems quite reasonable. So where should I start to draw? Yes. Yep. Yeah. Yeah. Yeah, great. So it is a slope less than zero, so I draw it a little bit flatter than the axis, which would just divide this sector. So maybe it looks like this. yd equals c0 plus I plus g plus cy times y, and this was 170 plus 0.9 times y, and this is c0 plus I plus g. This is the vertical cut. Well, and now this is this part of my model, but I have this part. And so that you can remember it from school, I write on the left side the thing which is on the vertical axis, because on the vertical axis you always have drawn f of x. So I have yd equals y. How do I draw this functional dependence between demand and income in my diagram? What kind of function does this represent? Let me rewrite this as O plus 1 times y. This is the same, or? Yep, yep, yeah, yeah. So this will be then a little bit steeper than this one, because this is a slope of 0.9 and this is now a slope of 1. Okay? This is yd equals y. And if I would have drawn it in the right way, and the units of the vertical and the horizontal axis would be the same, then I also know the angle here. This would be then 45 degrees. But this is only true if the units of the vertical and the horizontal axis are the same. And therefore, in many textbooks, you just find this here, this line as this is the 45-degree line. Well, but what is the interpretation? And this is the more important point, not just drawing it. What is the interpretation? Well, in the end, again, demand side view of the model of the economy. We have given demand, and then in the equilibrium process, production income is following our demand plans. So in the end, we assume always we have a match between demand and supply. And this match of demand and supply is just represented by setting yd equals y. So these points on this line are all possible equilibria in our economy. So it cannot be somewhere. It has to lie, our equilibrium income has to lie on this 45-degree line. But at this step, we have not directly what is equilibrium income, but only what is potentially equilibrium income. So all possible equilibria. Well, and now we take both together. This part and this part. And this means, well, we have an explicit dependence of demand on income. And this is represented by this function. And then, of course, the specific equilibrium has just to be the cut of these two lines. Okay? Y star equilibrium income of the economy. Well, and then here you also see that actually we need this vertical cut of overall demand, and also we need technically to obtain a reasonable result that marginal rate of consumption is smaller than 1, because with these two assumptions, that here we have a positive number and the slope of this function is a little bit flatter than the identity function, means that we definitely obtain a positive cut of these two lines. Okay, and now we have our equilibrium, and I think you also have talked about the market equilibrium, about the properties of the market equilibrium. And especially about, you have posed the question about stability. And this is also very relevant now to find out, is this a stable equilibrium? Because if it would be unstable, or if the market equilibrium, cut off demand and supply in general in the PX diagram would not be stable, then it wouldn't be that interesting. Because in general, of course, here we have a static approach. We say the framework is fixed And in reality, of course, we know the framework is not fixed. Always a crazy guy in the United States can step in and change everything. It's always possible. Yeah? So that we are always in an equilibrium, this is quite improbable. But if it's stable, then it's still very interesting because then we can argue, well, we are always in the neighborhood. Or if something changes, then we say, well, we can argue that now we have an adjustment process which drives us into the equilibrium. And therefore, now we have also to talk about, well, what happens if we are in the situation where we are out of equilibrium? What will then happen due to our assumptions? And do this behavior then also match with reality? And this we will do in a minute. But if you see my drawings here, and this I always do, is that you find the same picture with some annotations here, yeah, which looks hopefully a little bit better than my drawings and my handwriting. And there, but on the other hand, if I would just give you this picture and there you find very much information inside, I think it is better if I start really from zero developing this picture with you together. Okay, but now about the question of stability. Do we find here an adaptation process which drives us into equilibrium? And then let's start with this situation here with a starting income y0. And now in my following argumentation, be careful. This is not an argumentation in time. So what I now try to explain to you is a qualitative adaptation process, not this is a situation, then the next day this happens, the second day happens this, and so on. So there is no time dynamic right now in it, sondern we just ask ourselves if we are in the situation that we have this y0, we see this y0 corresponds due to our demand function with the overall demand which we find here. But then, with respect to our equilibrium condition, we see that this would be, yeah, somehow a surprise for the supply side. We have from the demand side, given this income, an overall demand plan, explicitly consumption, investment, and government expenditure, which would be equivalent to a production which has to be here. But the corresponding production is just this one. So in this case, we have to admit, okay, demand is larger than the production. Take my example from yesterday. I plan to buy 3 bicycles, and then I see, oh, it's only 1 bicycle produced. But maybe then, and I think here again about what we have talked about the circular flow, that maybe in some house behind that our bicycle producer has some inventories. Then he goes there, gets his 2 bicycles, and I can buy them. So in this situation, we have the situation that inventories will decrease. Oops, there's an I too much, but I cannot delete it right now, sorry. So how much would I decrease my inventory? Well, so that I, in opposite, increase production due to the corresponding level. So from this point, I go to my equilibrium condition and then I find it. I have increased production, but, sorry for this, I have increased income, but Keynesian consumption hypothesis, higher income means higher consumption. So this would then internally within our model also increase my consumption plan. And therefore, I still have a gap between total demand and total production. And this process qualitatively, not in reality, this is only, so to speak, the driving process. It drives me into the equilibrium. The corresponding demand level to this again increased production still does not match it. And then I can go on in the argumentation, but overall I obtain a force which drives me into the equilibrium. So from this side, I can say my equilibrium is stable. Yep. Name, well, it's a specific name we do not have, but it is, we can talk about the reason. And the reason here is the strong assumption that always supply is following demand. And demand is somehow here changing due to our assumption that especially consumption is increasing by increasing income. So this we can do. So just a word or a name for it we do not have here. Yep. Okay, well, and also be careful that you do not say, well, now I'm adjusting at first 2 bicycles and then one and then another one or so. This is a continuous process because also mathematically, this is also as we had it in the money multiplier, a geometric process. So it to just get into the equilibrium, we need infinitely an infinite number of steps. Okay, but then let's go to the other side. Let's starting at y0 prime, a larger income than the equilibrium income. Well, also we can then calculate the demand which corresponds to this income level. And this we find here. This is the demand of y0 prime. But then we see, okay, this demand level here is lower than the corresponding production level because income is production in. This is just the other side of GDP. So y0 would be here, y0 prime, sorry. So, and then we ask ourselves, again, due to our assumption, supply is following demand, what happens? So we have a surprise for the supply side in the other direction. Oh shit, I have produced too much. I cannot sell for the given price all my bicycles. What happens? I will increase my inventory. So a build-up of inventory. How much in the first step? Well, I go to the corresponding level again on the equilibrium condition. But what do I see? Unfortunately, y1 prime a decrease of income means also a decrease of my consumption plan. Lower income, lower consumption. Consumption is part of overall demand, so decrease of overall demand. Again, I have still a gap here. Same argumentation. Shit, I'm still producing too much, so I'm further decrease production or increase inventory. And again, I obtain an overall force into the equilibrium. And then I can argue this is stable. So overall, for y0 larger or smaller than equilibrium income, we obtain a driving force into the equilibrium, then y star is stable. Yeah, 10 minutes left. Now what we want to do is we are done, so to speak, with our model. And now we want to apply our model. If we can describe the economy, especially here the commodity market, via this model, here we have one policy parameter within our model. And the policy parameter is just the government expenditure. Every year in Parliament, we are discussing what do we want to spend by the government. Yeah. Pardon? Not again? Hmm? Oh, this has to be again consumption. Yeah. Thank you. Autonomous consumption. So, so what we now want to ask ourselves, what happens within our model if we start to increase government expenditure? And this I want to discuss with you at some example which we had 15 years ago, just in the aftermath of the financial crisis. Yesterday also we started to discuss the breakdown of Lehman Brothers, September 2009, and then we had the spillover to the real economy, and especially what you see here is the number of incoming orders. You see how dramatic they have fallen within some 1 or 2 months. This is end of summer, September, and this dropped by 30 points, the incoming order number. Or what we also see here, this I have already shown you when we talked about the business cycle, the drop down of production in winter 2008-2009. And then it was discussed not only in Germany, almost all over the world, well, what we can do about this situation in order to stabilize the economy. And in Germany, we invented in this time a tool called the scrappage allowance. I don't know, some of you are from Germany. Do you know what the scrappage allowance was in 2009? I think maybe you are between 5 and 10 years. You didn't have a driving license. Well, this was the following tool. You have had a functioning car because from the government side, similar as in our situation right now, why do we have an overall bad performance of our economy right now? Also, one reason is our core of our production side has a problem, our car industry. And of course, in this time, it was the same because especially the people from abroad didn't bought our cars anymore. Because more or less the whole economy in the world for some months somehow stopped because we didn't know well what happens there. And though it was the idea, how can we explicitly stabilize our core industry, the car production sector in Germany? And then it was the idea, well, we have functioning old cars in Germany. They are still driving. You could also still go from here to Berlin with these cars. But maybe they had an age between 5 and 10 years. It was old cars. And then I said, well, you go there and throw them away. You give me the certificate that you explicitly have thrown them away, and you buy a new car. And if you then buy a new car, and then you have to go to the Kfz Anmeldestelle, I don't know the English word for it, that you are allowed to drive on the streets. And when you then have showed, well, I have thrown it away and here is my new car, I want the license or the allowance that I can drive in Germany, then you obtain 2,500 euros. And the idea behind it was, well, if I give everybody 2,500 euros, throwing away a functioning car and directly buying a new one would be an incentive to do this, so to buy new cars. And overall, this was a pot of 5 billion euros. In this time, 5 billion euros was a large number after Corona and whatever afterwards. 5 billion is not that large anymore. But in these times, 15 years ago, 5 billion was quite a large number. Well, and then, yeah, at the first step, we could say, well, of course, this is an incentive to buy a new car. In general, this would stabilize the car sector. But then also the economists were asked, well, is this a good idea by the government? And most of them shake their heads. They said, well, yeah, at the first step, maybe, but it won't function because in general, a new car would be around 20,000 euros or something like this. You cannot buy a new car for 2,500 euros. So still every household have an increase of or have a large expenditure due to their income. And maybe they already had planned to buy some other large good. A new refrigerator for 1,500 euros or something within your flat which costs 5,000 euros. So a large expenditure. And then the argumentation was, well, if you put now an incentive into the economy to buy a new car, then just the other things won't be bought. So that you only have a shift inside the expenditure portfolio of the households, but you obtain no overall effect. This was one argumentation against it. And the other one was, I said, a new car, 20,000 euros. Well, look at the German car industry. This is Mercedes, this is BMW, Audi, and so on. So mainly more expensive cars. where a new car costs 40, 50, 60,000 euros. And then the argumentation was, well, so to speak, lowering the price of this very expensive car by 2,500 euros. This doesn't really matter. You don't really care about it if the price of the car is 52,000 euros or only 50,000 euros for you. So then the argumentation was, well, man, if there is a push, we will only push the other car industry, Skoda, Seat, Fiat, and so on, in the other countries of Europe. But what we see is, well, it really functioned. Within some months, we obtained the level, the former level before the crisis, and also we adjusted here very fast within 1 year, 1.5 years in overall production. So we have not seen this substitution effect, not buying other goods. And what we also have to say, well, it was quite a good idea. And if you have a good idea, then these good ideas will be adopted by others. Almost every other country in Europe, after we announced the scrappage allowance, they announced a similar tool. And so it was an overall push for the car industry, not only in Europe, but worldwide. And about the technical functionality of such an expenditure program within our model, we will talk next week. Okay, thank you very much for today.